Hello, so the title of this talk is Fudges in the Mathematics Used in Physics. There is numerous fudging of mathematics and physics, especially for Einstein's relativity. We'll only be able to deal with a few. Most famous is Einstein's cosmological constant fudge. So this is pointed out in Scientific American, February 2017. In Einstein's Cosmological Considerations paper of 1917, Einstein showed that general relativity could indeed give a consistent model of the static universe. However, two assumptions were necessary. First, the universe was of closed spatial geometry, like a three-dimensional sphere, and had no beginning or end in time. Second, a consistent solution necessitated the introduction of a new term to the field equations of relativity. Some regarded the new term, known as the cosmological constant, as something of a fudge factor, and claimed that it marred the symmetry and simplicity of the original field equations. That is what he introduced, and there's since been a lot of argument over keeping, discarding or modifying this fudge factor. Really, physics is built on a lot of fudge factors added to the mathematical models or theory to try to get the mathematics to agree with observations and experiments. As per Wikipedia, a fudge factor is defined as an ad hoc quantity or element introduced into a calculation, formula or model in order to make it fit observations or expectations, also known as a correction coefficient. Examples include a cosmological constant, dark energy, the initial proportions of dark matter, and inflation. So Wikipedia is noting that Einstein's cosmological constant is a fudge factor. Now going to deal with fudging outside of relativity. In my view, Einstein did fudging, and that encouraged physicists that came after him to follow his example to fudge in the rest of physics. So this is an interview with Dr. Chris Oakley at this website here. At the website it says, "We rely upon the leaders of modern science to tell us the truth, particularly when the subject is the nature of the very world we live in. But it's well known that modern physicists apply a gigantic fudge factor to the equations underlying their theories of the physical world. Data fudging didn't work out too well for certain proponents of global warming. Why is no one talking about this fudging that is occurring on a much grander scale?" Dr. Chris Oakley, who is driven out of the physics community for voicing objections to the fudging problem. However, you look at Dr. Oakley's website, he refers to this talk, and he's saying that being driven out of the physics community for voicing the objections to fudging is a bit of a dramatising it too much. He says it certainly was true to say that he did not leave fundamental physics voluntarily. Also, he's not an expert on global warming, so he was only complaining about fudging within the physics community. So this is the introduction to Chris Oakley's talk.
But when you fudge the data, when you alter the data to advance a preconceived notion rather than just look at the data, your thesis loses credibility. Now, this show is about fudging on an entirely different scale. It's not the sort of fudging we'll read about in Newsweek, the New York Times, or Scientific American. And it's not yet made the show 60 Minutes. But it may very well be the biggest and most outrageous fudging of them all. Our scientists, even those who won the Nobel Prize in physics, may be fudging the very theories of reality. Now, this is important because this theory, the quantum field theory, the standard model of particle physics, are taught in school, they're written in textbooks, and they're guiding the popular scientists' books out there on the shelves, including, for example, A Universe from Nothing by Lawrence Krauss talks about it, and Lisa Randall in her book Unraveling the Mysteries of the Universe's Hidden Dimensions also talks about fudging. But to challenge this fudging, to open up the problem, to expose it, is heretical in today's mainstream science. It's blasphemy. But let's ignore this problem for a moment, and let's just be scientific about it. Let's look at the facts. Now, today our guest is Dr. Christopher Oakley, who is kind enough to join us today from the United Kingdom. Dr. Oakley has a degree from the Department of Theoretical Physics at Oxford University, and then after spending some time in the academic community, he now works on programming for a number of financial institutions. Well, thank you very much, Dr. Oakley, for joining us. Welcome to the show.
Thank you very much. It's nice to talk to you.
Now, Wikipedia describes renormalization in this way. It says it's a collection of techniques in quantum field theory, the statistical mechanics of fields, and the theory of self-similar geometric structures that are used to treat infinities arising in calculated quantities by altering values of these quantities to compensate for the effects of their self-interactions. But even if no infinities arose in loop diagrams in quantum field theory, it could be shown that it would be necessary to renormalize the mass and fields appearing in the original Lagrangian. Now, Dr. Oakley is going to talk about normalization as fudging. Here's the talk.
Okay, now the reason why I wanted to have you on the show, Dr. Oakley, is that you've stuck your neck out and challenged the scientific use of this fudge factor. I think it goes by a bigger name. I think the name is called renormalization. Is that right?
Yeah, renormalization. I mean, shall I explain the etymology a little more?
Yeah. Why don't we set the table for the listener for a moment? Why don't you go ahead and explain this?
Yeah. Well, basically, quantum mechanics was a victim of its own success. It was devised originally around 1925, and within about 5 years, they were actually struggling to find new things to explain with quantum mechanics because it just seemed to be so good. Initially, it was to explain atomic spectra, but they were soon extending it to, that's just in very simple atoms like the hydrogen atom, but soon they were finding it was applying to pretty much everything they looked at. But one area where it fell down in was when particles are created and destroyed. Now, this happens quite a lot. Whenever you switch on a bulb, for example, what happens is the atoms move from excited to de-excited states, and in the process they create a new particle which is called a photon, and the photon is what comprises light. And the theory that they came up with, the quantum mechanical theory, was called quantum electrodynamics. The problem is it only works if you don't ask too many questions. And one of the original founders, Paul Derack, who's probably one of the most unsung heroes of physics, He's a very well-known physicist, but hardly known at all outside the physics world, and yet he was pretty much of the caliber of Einstein. He never accepted it. And Richard Feynman, who more people have heard of, never accepted it really either. But apart from those two, it's pretty much heretical to say that quantum electrodynamics doesn't work. And at the core of this non-functionality is this process called renormalization.
Yeah, okay.
So this is Paul Derack. He's a physicist, Nobel laureate in 1933, and referring to renormalization, he says it's just a stopgap procedure. There must be some fundamental change in our ideas, probably a change just as fundamental as the passage from Bohr's orbit theory to quantum mechanics. When you get a number turning out to be infinite, which ought to be finite, you should admit that there is something wrong with your equations and not hope that you can get a good theory just by doctoring that number. So by doctoring up, he means fudging, in other words. This is Richard Feynman, Nobel laureate in 1965, another famous physicist. The shell game that we play is technically called renormalization, but no matter how clever the word, it is still what I would call a dippy process, having to resort to such hocus pocus as has prevented us from proving that the theory of quantum electrodynamics is mathematically self-consistent. It's surprising that the theory still hasn't been proved self-consistent one way or the other by now. I suspect that renormalization is not mathematically legitimate. By hocus pocus is another way of saying it's fudging.
Okay, so we read a lot about how quantum electrodynamics is the most accurate theory ever devised, about how its predictions are good to several decimal places past the part in a billion, and its guides the working of technology, and it's the greatest thing since sliced bread. What is the underlying problem here?
The thing is, there's no sort of definite level at which the theory has to apply. So I could, if I'm allowed to come up with not very elaborate theories, I can explain an awful lot. If I want to come up with a very deep theory, then it's harder and there's more chance of it being proved wrong. Now, it's the way, if you're allowed to cheat in getting your 11 significant figures of precision in quantum electrodynamics, then of course we can get it. I mean, I can just say my theory is that the muon's anomalous magnetic moment is, and then write down the number, and I know that number from experiment, and then I can say my theory then works. The muon's magnetic moment is indeed that number. But what does that prove? The answer is not very much. I mean, they have the theory of quantum electrodynamics that is in operation now and has been for probably well over 50 years, is essentially one where they have allowed themselves to violate basic rules of mathematics. So even if they've got this position, it only raises more questions as to why, because there's no underlying explanation that goes back to the principles of quantum mechanics.
So he said about it violates the rules of mathematics, and he does say a lot more in that. interview, so I guess I just gave the highlights. At his website he also says a lot more. He says if one accepts the nonsense that is renormalization, is not a big step to accepting all sorts of other nonsense. And as I pointed out in my videos on criticising special relativity, there is quite a lot of nonsense in that. So accepting one sort of nonsense and you just carry on accepting more nonsense, and that's basically where we are. The mathematics is being fudged, which is nonsense. You're creating nonsense, and that's the state of physics today. And it's not just in physics they're doing that, they are fudging the maths wherever they can. Thank you. The end.